Number 1. Sensitile. Think about when you walk across your kitchen floor to grab some smoothies from the refrigerator and the floor glitters with a lighted path that guides your way through the dark room. Now, this is possible with Sensitile. Sensitile is a unique, luxurious, and highly durable tile that twinkles floors. It is crafted with concrete acrylic fiber optic channels that transfer light from one point to another. It features unique materials such as resin, glass, and terrazzo, a fine concrete mix embedded with light-conducting channels and formed into slabs or tiles that shift, shimmer, and glitter in response to light, movement, and shadows, playful and eye-catching. As a person walks on the terrazzo's surface, the light channels flicker with a randomized sparkling effect. The tile is available in various sizes ranging from 12-inch by 12-inch to a 1/4 inch by a 1/4 inch, and thicknesses ranging from 1 1/4 inch to 5/8 of an inch, with different color shades of black, blue, violet, green, and gray, so you can choose the perfect design to match your decor. It's also available in various textures, from the classic smooth finish to a more distinct raised pattern. Whatever your preference, Sensitile will bring a touch of luxury and elegance to your home. Number 2. Light-generating cement. Imagine a concrete slab that can absorb sunlight energy during the day and emit light at night. This exciting innovation will provide efficient solar energy and can be used in bathrooms, swimming pools, facades, and kitchens. It could also be used on roads as a sign because of its light-emitting properties. You might want to ask, how does this work? The technique is simple. The microstructure of the cement is modified to eliminate its crystals so that the incoming light can penetrate deep. To achieve that, materials such as silica, river sand, industrial weight, alkali, and water are mixed used. The newly formed light-emitting cement, when combined with water, changes completely to gel form. In the daytime, the cement acts as a storage device. During this time, the whole mass is soaked in sunlight, and the electrons within the mass are in an excited state. During the night, these electrons return to their original form, due to which light is emitted. This cement can provide light continuously for 12 hours without electricity. Dr. Jose Carlos Rubio developed this innovative cement at the Michoacan University of St. Nicholas of Hidalgo in Mexico. He claims that this light-emitting cement can last up to 100 years. Currently, the colors in light-generating cement are blue and green, and contractors can adjust the light intensity to meet the requirements. Number 3. Bio-coal lining. Climate change is one of the most unprecedented crises facing our planet today. From extreme weather conditions to the rising levels of greenhouse emissions, the effects of these changes are already being felt around the world. And this prompted the Berlin-based startup company Made of Air to develop a unique non-toxic bioplastic made of biochar. Their goal is to reverse the effects of climate change by producing carbon-negative materials. They trap carbon dioxide from the atmosphere and permanently store it in finished products that replace high-emission materials and other biomass waste streams. The result is a thermoplastic compound that can be shaped into a range of architectural goods, such as facade panels, and marketed to a broader market. This can transform products in consumer goods, tech, and the construction industry. Number 4. Hemp Rebar. In 2018, the I-35W bridge in Minneapolis, Minnesota collapsed due to its steel and concrete reinforcement failure. The bridge had been carrying over 100,000 vehicles daily across the Mississippi River for over 40 years. An investigation into the collapse revealed that the steel reinforcement bars were too thin and the concrete too weak, making the bridge unable to withstand the stress of the traffic. The tragedy claimed 13 lives and injured 145 people. However, researchers from the Rensselaer Polytechnic Institute in the USA claimed that such a tragic event could be avoided by using the hemp rebar they invented as an alternative to steel reinforcement to prevent the problem of corrosion and reduce carbon emissions during construction. Number 5. Cigarette butt bricks. Have you ever noticed the small, discarded pieces of paper from tobacco that are often left on the ground? Now that is cigarette butt. About 1 billion people smoke worldwide. Do you know how much waste those cigarette butts alone make globally? So, RMIT University in Australia has devised a solution to minimize waste and utilize it effectively in the production of bricks. To produce more sustainable, lighter, and energy-efficient construction materials, around 1% of the butts must be utilized. These extra features make bricks lighter and better at insulating. The insulating features reduce the cost of heating and cooling a home. Some researchers state that cigarette butts also reduce the suitability of bricks for load-bearing walls. However, the concentration can be reduced to match the requirements. Number 6. Self-healing concrete. In ancient Greek mythology, a story goes that a mystical species of bacteria lived in the depths of the sea. These bacteria had the power to self-heal and could replenish itself when injured. It was said that these bacteria could restore life to those who had died, so long as the body was not too far gone. This myth may have resurfaced in this self-healing concrete. In 2005, Henk Jonkers, an innovator from Delft University of Technology, demonstrated a groundbreaking technique for patching concrete cracks with bacteria. Simple capsules containing certain bacteria and their nutrients were put into the concrete, and when water touched them, the bacteria were activated. Concrete that had cracked had been repaired using moisture and bacteria-produced limestone. Again, some Korean researchers have developed a different solution that involves mixing concrete with capsules made of a specific polymer. It begins to react and swell when exposed to moisture and sunshine and fills the crack. Number 7. FlexiCum. As you might guess, FlexiCum is inspired by nature. Thousands of polypropylene tubes are tightly connected into a flexible matrix, which can be given different shapes. These structures are translucent, so they are often used for the manufacture of decorative lighting elements from the name. The design of this material is inspired by honeycombs. This very simple idea has turned out to be amazingly flexible and functional. The idea first appeared at Yale University, where researchers studied the honeycomb structure. By combining drinking straws into one array, it is easy to create a design resembling a honeycomb. It also offers the opportunity to recycle or upcycle a common plastic nuisance, the drinking straw. Number 8. Laminated wood. This material is cutting edge since it combines wood into every component. The wood is laminated and pressed into panels to create a solid block that is significantly stronger than regular wood. Intense beams are made from laminated wood, which is made up of many pieces of lumber joined together with glue. To make huge, sturdy panels, pieces of wood are put out in alternating directions to form cross-laminated timber. Both kinds of wood have a high level of fire resistance. When the outside layers burn, charring is produced to insulate the wood's inner layers. They showed the capacity to sustain their structural integrity during fire resistance testing. Utilizing solid wood helps to trap carbon when trees are growing and while wood is being used to construct buildings. According to research in the Journal of sustainable forestry may reduce world emissions by 14 to 31% by using substitute materials in construction. Number 9. Bending flexible concrete. These days, almost all construction is based on concrete. In 2014, Singaporeans were able to add flexibility, which is not a distinctive quality of conventional concrete. In addition to improving the strength and reducing the weight of concrete by removing reinforcing from concrete structures. The new concrete Conflex Pave offers flexibility and strength that are up to 3 times higher than regular concrete thanks to a special additive. The tiniest polymer microfibers are added to the mixture to distribute loads throughout the whole concrete surface. Due to this, when it's bent, it becomes twice as strong as conventional concrete and as strong as metal. However, there is no limit to perfection, and other researchers keep working on flexible concrete. For instance, Swinburne University researchers have created concrete without the use of cement that exhibits the same exceptional qualities in terms of flexibility and loads. This new kind of concrete is also eco-friendly as it incorporates fly ash and geopolymer composite, typical waste emissions from coal power plants. It also solidifies at ambient temperature, negating the requirement for high production costs. Most crucial, though, is that the new concrete is 400 times more flexible than conventional concrete, while yet being equally strong. In addition to increasing the flexural coefficient, geopolymers also strengthen the resistance to potential microfractures. The polymer fibers maintain the structure under pressure despite fractures, allowing the novel material to be employed in earthquake-prone locations where there is a reduced chance of building collapse. Number 10. Carbon fiber. Tornadoes and hurricanes are 2 of Mother Nature's most devastating and powerful forces. When they strike, they bring catastrophic destruction to buildings, so in a bid to curb this harm to buildings, researchers came up with carbon fiber. Carbon fiber is a polymer and is sometimes known as graphite fiber. It is a very strong material that is also very lightweight. Carbon fiber is 5 times stronger than steel and twice as stiff. Though carbon fiber is stronger and stiffer than steel, it is lighter than steel, making it the ideal manufacturing material for many parts. These are just a few reasons why carbon fiber is favored by engineers and designers for manufacturing. Carbon fiber is made of thin, strong crystalline filaments of carbon that are used to strengthen the material. Carbon fiber can be thinner than a strand of human hair and gets its strength when twisted together like yarn. Then it can be woven together to form cloth, and if needed to take a permanent shape, carbon fiber can be laid over a mold and coated in resin or plastic. Other features of carbon fiber are high in stiffness and tensile strength, has a low weight to strength ratio with high chemical resistance, and is temperature tolerant to excessive heat with low thermal expansion. Also, because of this, carbon fiber is very popular in many industries, such as aerospace, automotive, military, and recreational applications. The future of revolutionary building construction technology is here, and it keeps blowing our minds. The possibilities for faster, smarter, and more efficient construction are endless. So, what will be the next great leap in building technology? How will these advances change the way we build and interact with our built environment? Let us know your thoughts in the comment section, subscribe to our YouTube channel, and get the latest updates on the best construction technologies available. Thank you.